Good morning, geometry guys. It's Mr. Jeffers coming at you from my first period class again, so hopefully we don't have such a rootin' tootin' time as we did yesterday. Don't forget, hit like, subscribe, the bell. Now, today we are looking at right triangle trig. Okay, now, right triangle trig. It can be difficult if you let it. If you try to overthink what it's asking. Okay? Now, why does this stuff look weird? Because it's in a different language. Okay? It's actually Greek. Alright? And we're going to be looking, this is our Greek letter that we're going to be dealing with. It looks like an O with a line through it, and it's pronounced theta. Theta. Okay, now, this is pronounced sine. Okay, this is sine, not sin. I don't know why they just took the E off to do shorthand. It doesn't make sense. Okay, so sine of theta. That means if we're at this angle right here, it's our opposite side over the hypotenuse. Okay. This is actually cosine, all right? And if this is our theta, our adjacent, the one right beside it, not across, but right beside it, over the hypotenuse. And then for tangent, okay, we would actually have our opposite over the adjacent. Okay, now each time we're looking at this, it's almost like you're in a corner and you're looking out. Okay, because the view from where the 85-inch screen is different than the view from where the 70-inch screen. All right. So, does everybody have any extra stuff that I wrote down to write down? Remember, if I write something down, it may be important. Okay, hold on. Now, so, we're doing this one right here. It says, find the trig ratios for the following. Okay. Looking from theta, we are in this corner, okay? Which number is opposite of theta? 12. Which number is adjacent to theta, which is right beside it? 5. Now, it's not 13. 13 is the longest side. It's the hypotenuse. A lot of people get that confused. Now, what? I said the adjacent is not 13. No, I had actually moved on. So, all right. So sine is our opposite, which is 12, over our hypotenuse, which is 13. And that's all you have to do. If you want to see if it reduces, then you'd actually, get this out. You would say, 12 n over d 13. Enter. Okay? And you would see if it would reduce, but this one doesn't. Okay. All right, cosine. This is our adjacent, which is 5, over the hypotenuse, which is 13. All right, our tangent. This is our opposite, which is 12, over the adjacent, which is 5. And that's it. We just leave these. Now, you can check them with the calculator to see if they reduce, but this is it. A lot of people try to make this harder than it has to be. It's like you're in that corner looking away, because if I'm in this corner, the side that's opposite is not the same if I'm looking in this corner. Okay, the wall that's opposite of the 85-inch is over there where my desk and stuff is. The wall opposite of where the 70-inch is over here where it's got the days since someone almost hit traffic cone Carl and all that other stuff on it. Okay. Like most things in life, it's about perspective. All right. So, let's look here. Here's my theta. I'm looking for my opposite, which is 15. That means my adjacent would be, and the hypotenuse is 17. Once you find those three things, it's literally just writing stuff as a fraction. Okay? So sine 15 over 17, because it's opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. All right. Now, should be straightforward. So I know it's not written down, but it is. You have to fill out these blanks. You have to find the opposite, adjacent, hypotenuse before you find sine, cosine, and theta. Okay. All right. Let's see. There's one of these I need. On the second problem on your practice, I would check for reducing. Okay? On the second problem of your practice on the back, I would check to see if it reduces. And I think that's it. Yeah, just that one. All right. So that's it for the lesson. Don't forget to hit like, subscribe, hit the bell. Good stuff, good things. Roll Tide.